Welcome everyone. Today I'll be solving question number 51 of the 2022 GATE Biotechnology paper. And the question states that you have to find out from the given statements which are or is correct regarding the Lac-operon in E. coli when grown in the presence of glucose and lactose. There are four options given to you. Option A is at low glucose level, the operon is activated. Option B is at high glucose level, the operon is activated to enable the utilization of lactose. Option C is that the Lac repressor binds to the operator region, inactivating the operon. And option D is that the binding of lactose to the Lac repressor induces the operon. So before we move on, let's see why an operon in this case is required. So when you grow E. coli in a media which contains two or more carbon sources, it doesn't utilize those carbon sources together, it utilizes them sequentially, like you can see in this case. So instead of the E. coli using glucose and lactose together, it first uses up glucose and then the lactose. That is why you find two lag phases and log phases in this. So like you can see here, the E. coli undergoes a lag phase and then a log phase or the exponential growth where glucose is being utilized. And once the glucose is used up, it enters another lag phase and a log phase where the lactose is used up. And then finally a stationary phase. And this sequential use of carbon source or the dioxide growth that you can see here is due to the Lac-operon. Now let's rewind and see what the Lac-operon actually is. Lac-operon is a portion of the genome of the E. coli, which contains a promoter region, an operator region, and the genes. There are three genes which are involved in the conversion of lactose to glucose and galactose. So what happens when there is no lactose in the media, like you can see in the first case, is that the Lac repressor can bind tightly to the operator region and it hinders the RNA polymerase from binding to the promoter region. So it prevents the transcription of the three genes in the Lac-operon. And when lactose is present in the media, or if only lactose was present, what happens is that the repressor is bound to the allolactose. Okay. And since the repressor is now bound to the allolactose, it cannot bind to the operator region anymore. Okay. And because of that, the RNA polymerase can now transcribe this operon. Now, another two cases that you need to keep in mind are the presence and absence of glucose. So when there is low glucose in the media, like you will observe after the glucose has been utilized, CAMP or cyclic AMP is produced. The CAMP attaches to cap and that cap binds to the cap binding site, which is upstream of the promoter region for the Lac-operon. And this helps the RNA polymerase to bind to the promoter more frequently and increases the levels of transcription. But when there is high glucose in the media, what happens is that CAMP is not produced. So CAP or cap cannot bind to the cap binding site. Okay. So even though the RNA polymerase is bound to the promoter, transcription occurs at very low rates. Okay. And even if cap is bound to the cap site, if there is a repressor present, it can still stop the transcription of the Lac-operon. Okay. So now that we have seen all the four cases, let's go back and see what the answers are. So the correct answers are A, C, and D. So like we saw, at low glucose level, the operon is activated, which is correct. The second option is the opposite of option A, that is at high glucose levels. The operon is activated to enable the utilization of lactose, which is not true. At high glucose level, the operon will not be activated because the glucose will be being utilized at that point, right? So there is no need for the production of enzymes required for the breaking down of lactose. The option C is that the Lac repressor binds to the operator region, inactivating the operon, which is correct. And the option number 4 is binding of lactose to the Lac repressor induces the operon, which is also correct. So the correct answers are A, C, and D in this case. That is it for the answer for this question. I hope that was easy for you to understand. Thank you so much for listening.